Okay, now we're going to get into simplifying expressions with rational exponents. So first, a little review of our exponent rules. We used to cover these in Math 81, beginning algebra. In the textbook that I'm basing this lecture off of, these are covered in Chapter 5. You have your product rule, your power rule, power of a product rule, power of a quotient rule. You have your quotient rule, you have your zero exponent rule, and then we just reviewed the negative exponent rule. Okay, so those are the rules we're going to be using in this next batch of problems. Okay, I think I only have 2 of those to start with. Use the properties of exponents to simplify each expression. Write with positive exponents. So we're going to do these 2 examples to start with. All right, going back to the tablet. All right, first we have a to the power 1/4 times a to the power negative 1/2 divided by a to the 2/3. So this is definitely one of those occasions when I say think of a simpler, happier time. So the simpler, happier time was when the exponents were all integers. So like a to the 5th times a to the negative 2 divided by, let's say, a to the, I don't know, 4th. Okay. All right, so what would we do with that? Well, one thing we could do is we could add the exponents on top. Now, why don't we just go ahead and do this problem as a warm-up? So we could say 5 plus negative 2. 5 plus negative 2 is 3. Okay, and then the rule that talks about what to do with this is the quotient rule. 3 minus 4 is negative 1. And because that exponent is negative, we're not going to leave it like that. We're going to write the answer as 1 over a. All right, so that's what we would do. And that's what we're going to do again. Okay, it works the exact same way. So we'll start by adding the exponents on top. A to the power 1/4 plus negative 1/2. So I hate to break it to you, but you're going to be adding and subtracting fractions when you do these. 1/4 plus negative 1/2. You're going to think of that negative 1/2 as negative 2 over 4. So 1/4 plus negative 2 over 4, that's going to be negative 1/4. So we're going to have a to the negative 1/4 divided by a to the 2/3. Okay. All right, so now I can use my quotient rule. When you divide 2 powers, you subtract the exponents. So that's going to be a to the power negative 1/4 minus 2/3. Once again, we have to get a common denominator, which would be 12. So we'll rewrite that negative 1/4 as negative 3 over 12. We'll rewrite the negative 2/3 as negative 8 over 12. Right? So we're doing the top and the bottom of this one by 3. We're doing the top and the bottom of this one by 4. All right, and then negative 3 over 12 minus 8 over 12 is negative 11 over 12. And you don't write your answer using negative exponents, so you would write that as 1 over a to the 11 12ths. All right, so in my opinion, the only thing that's slightly annoying about these is having to do the like denominators for the fraction exponents. All right, next. The fourth power of 2x to the 1/5 divided by x to the 3/10. So the rule that talks about what to do with exponents outside parentheses is, I remember saying these to you in the last section, it's kind of like a distributive property. We're going to put the fourth power on the 2, and we're going to put it on the x to the 1/5. So we have 2 to the 4th, and then we have x to the 1/5 to the 4th. And then we're going to divide that by x to the 3/10. X to the 1/5 to the power 4, that's when you multiply the exponents, right? So we do 2 to the 4th is 16. And then 1/5 times 4 is 4/5, right? And then we divide that by x to the 3/10. Okay, so now I'm getting ready to do quotient rule again, where I subtract my exponents. So this is going to be 16 times x to the power 4/5 minus 3/10. The common denominator is 10. So we're going to do the top and the bottom of this one by 2. And that is going to give me 16x to the 8/10 minus 3/10. 8/10 minus 3/10 is 5/10. And of course, 5/10 is just 1/2. So you would write this as 16x to the 1/2. All right, not too bad once you get a little practice. Let's see what else we got. Yes. So a little multiplication problem, y to the 1/2 plus 5 times y to the 1/2 plus 5. And after that, we're going to do this little factoring problem. So I've said this to you once or twice before. My assumption when I teach Math C is that everybody is going to end up in calculus someday. That's what this class is intended for. Okay, now whether or not that's actually in your plans, I don't know, but I have to prepare everybody for calculus. So the kind of factoring problem you see there is one that does come up in calculus. Okay, so let's see how that works. But we'll start with the little multiplication problem. So this is just FOIL, right? We can just FOIL this, F-O-I-L. All right, first would be y to the 1/2 times y to the 1/2. Outer would be 5y to the 1/2. Inner would be 5y to the 1/2. And then last would be 5 times 5. Okay. What is y to the 1/2 times y to the 1/2? Well, you would add those exponents, 1/2 plus 1/2. And 1/2 plus 1/2 is 2/2, right? It's 1. So this term is going to be y to the first power, or just y. These two terms here are like terms. The y's have the same exponent. So we're just going to do the same thing we do with 5y cubed plus 5y cubed. We're just going to add the coefficients. So those are going to combine into 10y to the 1/2. And then we'll just do 5 times 5 is 25. So when you multiply y to the 1/2 plus 5 times y to the 1/2 plus 5, this is what you get. All right. And then on to the little factoring problem. They're asking us to factor y to the 2/7 from y to the 3/7 minus y to the 2/7. So let's talk about the simpler, happier times version of this problem. was when we had a polynomial like x to the third minus x squared, and we had to factor out the GCF, which of course is x squared. So how did that work? We would write the x squared out front. And then I remember when we first started reviewing factoring, I said, imagine there's a thought bubble there where you're dividing everybody by x squared. And that'll tell you what goes in the parentheses. So x cubed divided by x squared, that's just x. And then, of course, x squared divided by x squared is 1. So it works the same way in this problem. We're going to park the x to the 2/7 outside. And what are we going to have inside? Well, you could do a thought bubble. Divide by x to the 2/7, divide by x to the 2/7. 3/7 minus 2/7 is 1/7. So that would be the first term. And then x to the 2/7 divided by x to the 2/7, that's 1. It's a number divided by itself. So when you factor x to the 2/7 from x to the 3/7 minus x to the 2/7, this is what you get. All right, now if I'm not mistaken, there's only one thing left. Yes. All right, so miscellaneous using rational exponents to simplify radical expressions. So the first problem says to use rational exponents to simplify the radical and assume that all variables represent positive numbers. And then in the second problem, I love these. These are a lot of fun. Use rational exponents to write the expression as a single radical expression. So believe it or not, there is a way to rewrite the cube root of 5 times the square root of 2 as a single radical. So it'll be the somethingth root of something. All right. So we have to figure out what that is. All right. So for the last time today, we'll go back to the tablet. And our first problem is to use rational exponents to simplify the 8th root of 4y squared. So that use rational expressions, that's a really valuable hint. So what do I know about rational exponents? Well, I know that 8th root means 1/8 power. Okay. All right. So the next thing I'm going to do is I'm going to use my product to a power rule. That's the thing that I always say looks kind of like a distributive property. To rewrite this as 4 to the power 1/8 times y to the power 2 times 1/8. Okay. All right. Now we'll come back to 4 to the 1/8 in a second. That's the part that's a little weird. 2 times 1/8 though, what is that? Well, 8 divided by 2 is 4, 2 divided by 2 is 1. That's just y to the power 1/4. Okay. So I think this might have something to do with 4th root. But now what am I going to do with the 4 to the power 1/8? That's the tricky part. Well, what if we do this? What if we rewrite the 4 as 2 squared? Then we can do the same thing that we did with the y, right? This will be 2 to the power 2 times 1/8. 2 to the power 2 times 1/8 is going to give me 2 to the 1/4. All right, so believe it or not, the 8th root of 4y squared can be simplified down to 2 to the 1/4 times y to the 1/4, which I'm going to think of as the 1/4 power of 2y. And now I can just write it as the 4th root of 2y. Okay, so we've made the index smaller, and we've also made the radicand smaller. Okay, so that's a little nicer to look at, 4th root of 2y than 8th root of 4y squared. Okay, and now on to my favorite problem, the cube root of 5 times the square root of 2. So we're going to start off by rewriting this as 5 to the 1/3 times 2 to the 1/2. Now, unfortunately, there is no exponent rule that talks about how to simplify this kind of expression. There is a rule that talks about what to do when the bases are the same. And there's even a rule that talks about what to do when the exponents are the same. Okay. But there's no rule that talks about what to do when they're both different. So here's how I'm going to deal with that. I am going to first write those exponents so that they have the same denominator. So I'm going to multiply this one by 2/2. I'm going to multiply this one by 3/3. So that's going to give me 5 to the power 2/6 times 2 to the power 3/6. Okay. And now I am going to do this. See if you can see where this comes from. All right, so it almost reminds me a little bit of factoring. I'm peeling out that 1/6 because 2 times 1/6 is 2/6, and 3 times 1/6 is 3/6. Okay. All right, I think I can finish this off in the space we have left. 5 squared is 25. 2 to the 3rd is 8. 25 times 8 is 200. So I bet you never would have guessed, and I think this is one of the reasons that I enjoy these problems so much, is it's very hard to predict what the answer is going to be. It turns out that the cube root of 5 times the square root of 2 is equal to the 6th root of 200. Kind of hits you out of nowhere. All right. And that is going to take care of section 10.2. We'll see you next time.